chapter 19, okay, that if we were to integrate a definite integral, okay, to be precise, a definite integral, one of its applications would be the area above the x-axis, okay, between the graph, the curve and the x-axis. Then also, if the curve happens to be below the x-axis, we will need to consider modulus. And then if you are looking at the area between the curve and the y-axis, we have to change the equation to be in terms of y before we integrate with respect to y. Okay, that is what we have covered previously. Okay, let me continue with try 6 because I understand that I did not finish going through that question, right? Okay, I went through what? This was the one.
Yeah, you did.
I finished already, right?
Definitely. You just.
Yeah, because I said that you also in fact do triangle. Correct? I remember doing that. Okay, so that's not in try 6. Let's look at exercise 19.1. Question 19. Okay, so we are given that the diagram shows part of the curve y equals to 10 over x squared. We want to find the value of k for which the area of region P is equal to the area of region Q. Okay, sorry, my diagram might not actually illustrate this idea of equal. Okay, but that is what the question actually says. Okay, so we want to find out the value of k. How should we go about doing it? What should we do? We will have to form an equation. So how do we form the equation?
Integrate
Integrate what?
the y.
Okay, so we integrate 10 over x squared with respect to x, then so.
Then you put the definite
The boundary 5 to k, then
5 to k then
k to 2.
k to 2. Okay, so actually should be 2 to k, and then after that another one from k to 5, is it?
Equal.
They are going to be equal. Agree? Okay, so then after that we can integrate 10 over x squared, right? What is that going to be?
Then over x.
10 over x squared, how do we integrate that?
Then x over x. Then over negative 10 over x.
Okay, maybe let's change our indices first.
Negative 10 over x.
Negative 10 over x. Then after that we do the substitution. In this case, this will give negative 10 over k plus 10 over 2.
The negative.
Huh?
Negative 10 over.
Correct, negative plus.
Oh.
Right?
Plus 5.
Okay, so we will be able to get k to be equals to 2 and 6 over 7. you a diagram, okay, that shows you part of the curve for y equals to x squared minus ax minus b, so it's a quadratic curve. And then it says that it cuts the x-axis at P and at Q. Then after that, it also cuts the y-axis at R. And then the question also went on to say that there is a minimum point y negative 4. So this is a minimum point. Okay, so first part of the question, they want you to find the values of A and B. Okay, what will you do? Substitute the minimum point, okay. I can erase already, right? Sorry. Okay, so what will you do in this question 20? How to find A and B? We will substitute 1 negative 4, is it? Let's give that a try. So, at the minimum point, negative 4 equals to 1 square minus A, 1 minus B.
We need two equations.
Okay, so maybe let me simplify this. This is 1 plus 4, 5. So A will be equals to 5 minus B. Okay, how will we develop the next equation? Sorry? 2 dy over dx, okay. So dy over dx, 2x minus a. So this will be 0 at the minimum point. Agree? So 2, 1 minus a equals to 0. Oh, so a is equals to 2. See? Then after that, we will be able to find that. Let me just swap this around. So therefore, b equals to 5 minus 2 equals to 3. Okay? So any other proposed ways? Completing the square, good. Okay? So we could also do completing the square in order to match up with the minimum point. Okay? Because this is a quadratic curve, if you were to do completing the square, okay, we would be able to compare it with the turning point itself. Right? So let me just show another method. Okay, so if we have this equation, how do we complete the square? Do you all remember? Okay, remember we take the coefficient of x divided by 2. Okay, then after that, we have to minus away that one square. Do you all remember that? Okay. I will not go on to elaborate. Do you want me to elaborate why completing a square works this way? Again? Hello? Are you all still in holiday mood?
No.
Or was there ever holiday?
No.
Do I need to go explain why completing the square works this way?
No.
Yes? Okay, let me just unpack this again. Okay, because our completing the square, okay, because this one actually comes out to be x squared minus 2ab, right? Then plus a over 2 squared, correct? So this actually simplifies to become x squared minus a over ax plus a over 2 squared. So we have the x squared term here minus ax over here, but we have a minus b, but this is definitely not minus b. Okay, so that's why we always bring down the minus b here. Then after that, since we're adding up this a over 2 square to form this square part over here, we need to minus away that constant so that it becomes 0. That's why our completing the square method always remains to be this. You understand what I'm saying? Okay, so that's just a 1 minute crash course. Okay, So let me erase this part. Okay, so continuing from here, we know that we can look at the completed square form for us to find out what is the minimum point. You all remember that? Okay, so the minimum point would actually be looking at this part over here as well as this part over here, right? Okay, so the minimum is when your square part is actually equals to your square part is equals to 0, because that is the least value that you can actually go to. Okay, so x minus a over 2 will actually give you it will have to give you 0 lah. So your x value, try to say this. So since 1 negative 4 is the minimum, okay, so this part here will actually be equals to 1. So negative a over 2 equals to 1. Okay? Sorry, a over 2 equals to 1. Alright? Okay,
No,
then
one
after that,
What are negative?
because this one when it is equals to 0, the x value will give you a over 2. Alright, so x value will be 1. So a over 2 is equals to 1. Alright, so when this whole part is equals to 0, then this will actually give you the y coordinate.
Find the x coordinate. Let's see. X minus 1 square.
So we will still likewise be able to get a equals to 2 and b equals to 3. Okay? I'm just throwing out all these methods, just in case we need to explore this method. But of course, the original one that you were thinking about, it also works as well. So then in part 2, we want to find out what are the coordinates of P, Q and R. So since we have already found out what is A and B, so it's just a matter of solving. Okay, so we will be able to get P and Q will be at negative 1, 0 and 3, 0. Okay, please follow the diagram. Okay, any questions so far? Okay, next in part 3, we want to find the area of the shaded region. How will we find the area of the shaded region? How to find the area of shaded region?
Find the area of triangle.
Okay.
Then find the area of the entire thing under the x-axis.
Shoelace.
The integration of the.
Cannot do the shoelace method. Why is it that shoelace method cannot work?
Because curve.
Because it's a curve, shoelace method only happens for quadrilaterals. Okay, so therefore in this case we will have to consider the area of the curve to the x-axis minus away the area of the triangle. Agree? So how do we find the area of the curve to the x-axis?
Integration.
Okay, so integrate what and what? This is a negative 1
Y equals
and this
to
is 3.
Y equals to x. The
Integrate.
Integrate what?
X
x square minus 2x minus 3 dx.
Okay?
Then you define the negative 3.
Negative 1 to 3. That's all?
Modular.
I must have modulus, because this is below the x-axis. Okay? Then after that, minus away the area of the triangle. How do we find the area of the triangle?
Half time.
Half times
Okay, we can half times base times height, right?
half times 4 times.
Anybody don't understand why half times 4 times 3? Understand, right? Okay. So therefore we integrate this one.
X cube over 3. X.
Okay, so we get 4 and 2/3 units square.
Nine minus 9. One
Sorry.
negative 1 cube over 3.
Eh? Oh yeah, sorry, complete wrong. 3 and 2/3. 3 and 1/3, right?
3 and 2. Minus 1/3.
Oh, 3 and 2/3. Sorry. Huh?
The one
Quite A, 4 and 2/3 what?
but the one over 2. No, the one over one the no, we got 9 right?
What are you talking?
The 1 2/3
Uh-huh.
is 4. Wait.
This is 1/3, right? Minus away 1.
Oh my god.
Bye. Officially all
Just this calculator. Then, yeah. And then can I just have a sense in how many of you have CCAs on Tuesdays? Tuesdays.
Just soon.
Is it a self-prep?
Just soon.
Self-prep.
No, I don't know. I think soon is Monday, Tuesday, Wednesday, Thursday, and maybe Friday is. Tomorrow all extra have to go. So I will
Huh? Oh, as in your bond band for men. Don't you already have people bonding your CCA in the first place?
That's right.
And then you're going to make it further, make it worse further.
Further differentiation.
Further Then which is the day when everybody has CCA?
Sunday.
Yeah, Sunday.
Even Saturday also don't have.
Saturday got 13 you go for a concert Saturday.
Yeah, we got band exchange on this.
Why you give them rose?
What?
Why you so nice?
Why I give them rose? Because I want to support the service learning, ma.
Oh.
Okay, better. Yeah, okay, sure.
But I thought that it's a practice. I gave it to my set force last year, so I must give it to support. What?
Service learning.
Service learning.
Five rose.
Yuriko, you're jealous, is it? You want a flower?
Because Amelia was like, I love this. She keeps saying
I don't know, sometimes I don't know whether Amelia is being sarcastic or not.
she said she'll get A1 for you, so you remember, okay?
Okay, can we get back? We only got 10 minutes left.
Yeah.
What, shelving competition get flower, right?
You want a flower?
Maybe it's for camera.
Okay, I will cut it. Okay, try 7. Okay, we are looking at 19.2 whereby we want to find out the area between a curve and a line. Okay, basically the concept remains the same, just that for between curve and line, right, okay, we need to do some subtraction, okay, for us to find out what is the area. Okay, so let's look at the diagram that we have here.
What less? What less?
Yeah.
What is that? Modulus.
Why is that modulus? Because this one was area under.
What is that? Oh, it's a
One.
1.
Okay, so this is the diagram that we have. We have a curve that has the equation 8x minus x squared. Then after that, a line y equals to 7. Okay, we want what the question is asking, what is the area of the shaded region bounded by the curve and the line. So this is the shaded region that we're trying to find. Okay, so in order for us to find out what is the area, okay, we will likewise apply our integration. So if you were to integrate the curve itself, you're going to get the entire thing below the graph to the x-axis. Okay, but then after that, we also need to minus away the area below this part, right? Okay, so but the thing is that is it sensible? Are we able to find out what is this entire part? Are we able to find out this area for us to minus away?
Just find right? Then just
Okay, good. So we cannot actually take the entire curve, okay, from 0 to 8. Okay, we cannot take the whole area like we just use. Okay, I cannot find this entire green area, minus away the red area in order to get the black area. Because the red area cannot really be found. Okay, because if I want to integrate the area under the straight line over here, it will only be between here and here. Okay, so we are not able to find out these extra parts over here. Okay, unless you want to go and find out what is this value, then after it's 0 to here and then this part 8, which seems to be a bit troublesome.
No, why?
Okay.
Because the line is 7, like just one straight line.
Yeah, this is one straight line. Okay, so I will need to find out, we are only able to find out the area below the line for this rectangle here, but we do not know these parts, although we can find the parts. Okay, but it seems like it's extra work. Okay, when we can actually find a simpler way of doing it, okay, which is to consider the area under, what is this back? Okay, area under this curve here from P to Q. Okay, so we need to find the coordinates of P and Q, or rather the x coordinate of P and Q. Okay, so we find out this entire area here, then minus away the rectangle, which is also the area under the straight line. You understand what I'm saying? Okay, so first we find out what is the coordinates of P and Q by looking at the intersection between the curve and the line.
is 7.
Wait now. Sorry, repeat.
Boundary is 7 and 1.
Integration, yeah.
But then the equation will also be here. Let's just take y equals to 7 as the x-axis.
Uh-huh.
So this shape can be 7, boundary 7, 1. Then ax minus x.
8x minus x squared.
Alright, so I had a slight aversion to those.
So the area of the shaded region would be to integrate the curve from 1 to 7 because P is at 1 and then Q is at 7. 8x minus x squared. Then after that minus away the rectangle. Okay. So the rectangle itself, actually I need not consider integration at all. I could simply use length times breadth. Okay, so that will be 7 minus 1 times the height 7. See? Why do I need minus 0? Because I only want the shaded region.
Yeah, but that part,
We are left flowers and nice.
what if you so equating 7 and 1, right? It's like the y equals to 7 can also be the two x-axis, right? Like assuming that the x-axis.
Oh, how can you be the new x-axis? It's not even the x-axis.
But the equation on the line will be the same. So it's 1 plus 1. Like the x-axis up.
How can I move the x-axis up?
Because the equation will be the same.
Yeah. So how do we want to think about moving the equation? I understand your discussion.
I feel like it will be
Why are you moving? Because the area under this curve will always be this entire section. If I integrate the curve from 1 to 7.
But if we draw another graph, right, and we draw the upper part of the row,
So you want to shift the graph? Shift it down by 7 units. Why 4 units? So complicated. Then what if I don't give you a horizontal line? What if I give you a vertical line? Then it doesn't work.
if we shift it down, the 2 points is still there.
I don't recommend your thinking. Can you abort your thinking? You can yeah. That you take 8x minus x, you consider integrating from 1 to 7 for 8x minus x squared minus 37 and shift the curve down. You can consider that that should give you the same answer.
Oh, sorry. I couldn't understand why you did the answer. And you said equation answer. I didn't
So you understand now. Because it's online. Okay, any questions? I'm gonna check my notes. No? Alright, tomorrow we will just finish out try 8, try 9, and then after that one more question on 19.2. Then after that, that's it for chapter 19. Then we can go into chapter 20 on maybe Thursday. Alright? So, yes.